All right, so in this next section, we're going to look at everything we've done now in trigonometry, which really hasn't been that much, just finding your derivatives and making sure that we're okay with using chain rule with trig functions. And so now we're going to launch into some curve sketching with this. So a lot of the same rules apply to curve sketching still. Nothing really has changed. The process is all the same. They're just going to perhaps look a little bit different than they were when it was polynomial or rational or whatever else that we were looking at before. Okay, so these procedures the same as before. Determine your domain, determine your x-intercepts and your y-intercepts. With all of these, determining any asymptotes, that includes we might look at oblique asymptotes using a first derivative test to determine where your function is increasing or decreasing, first and second derivative test to determine relative extrema, and then second derivative test for points of concavity, inflection points. And then once we're done with all of that, we're going to throw it all together and sketch our graph. So example 1, we're going to look at the function y is equal to cos x minus sine x. We're just going to look at the interval from negative pi to positive pi. And here we go. Okay, so to start off, 1 is determine our domain. So our domain is going to be x such that negative 1 is less or equal to x is less or equal to, no, it's not. No, it's not. Negative 1, I had sine and cos in my head, and range. Okay, so negative pi, let's try that. Negative pi less or equal to x, less or equal to positive pi. All right, number 2 says determine your x-intercepts and y-intercepts. So with number 2, we're going to let y equals cos of 0, sine of 0, and it's equals to 1, 0. So therefore, x is 0, y is 1 is our y-intercept. If we are finding an x-intercept, we are letting y equals 0, and we get 0 is equal to cos x minus sine x. Add sine x to both sides, we have cos x equals sine x. And where does this happen? This happens, of course, on your 45s, or in this case on pi quarters, because we're in radians, of course. This happens, comma 0. What's our other one? Be careful, it's not 5 pi quarters, because our domain goes from negative pi to positive pi. And so because of that, pi quarters and negative 3 pi quarters. Those are our x-intercepts. Number 3 is asymptotes. We have no vertical asymptotes. Our limit, x goes to infinity, does not exist. No horizontal asymptotes either. It's not settling in on a number, cos x minus sine x. Both cos x and sine x are fluctuating between negative 1 and 1, and when we subtract those are all going to be values that in theory fluctuate between negative 2 and positive 2, and as we go to infinity, there is no limit that exists here. So number 4, we've got first derivative test to determine where we are increasing or decreasing. We take our first derivative of this, y prime. The derivative of cos is negative sine, and the derivative of sine is cos x, so it's minus sine x minus cos x. If we're looking at our first derivative test, we're letting y prime equal 0, and y prime equals 0, negative sine x minus cos x, and we end up with cos x equals negative sine x. Where does that happen? Of course, that happens at 3 pi quarters here. Remember that 3 pi quarters, we're going that way, and negative pi to positive pi for our domain. So those are our two solutions. So therefore, and whether or not that's clear to you or not, perhaps if we take it one more step and divide both sides by cos, we get 1 is equal to negative tan x. Tan is negative 1. So whether you want to take a step further and look at it like from there, or whether you see it from cos x equals negative sine x, either way. So we end up with critical numbers. We have x equals negative pi. We have x equals negative pi over 4. We have x equals 3/4 pi. X is equal to pi. That first and last one are our endpoints. And if we look at that, and let's draw a number line. Let's move it over here just a little bit. Let's say here's our y prime number line. It goes from negative pi to positive pi. Here's negative pi quarters. Here's 3 pi quarters. And we are looking to see what the value does in each of these intervals. Between negative pi and negative pi quarters, so we're going to have to pick some sort of number that's between these. So between negative pi and negative pi quarters, we are looking at our first derivative. We're looking at, say, a number like negative pi halves, right? So down here, if we've got negative pi halves, then we end up with a positive sign. Wait a second. Yeah, no, that sounds fine. And so we end up with positive there. So what we could be doing here is we could thinking about what sort of number is in here, and if we think, okay, so negative pi halves, if we think about down here, if we're plugging that in for x back in our first derivative, that'll be the negative of negative 1 minus 0. So that ends up being positive 1 at that point. That's what we can be looking at. You can also jump into your calculator and figure out another value that's in between there, and just plug these in your calculator. Make sure that you're in radians, and we can go ahead and just do that. Between negative pi quarters and 3 pi quarters, of course, maybe we look at 0 and take negative of sine 0, which is 0, minus cosine 0, which is 1. So minus 1 makes this negative in this interval. And then our last interval between 3 pi quarters and pi, this is maybe a place where we would consider either jumping into your calculator. We don't have to do it that way. We could take pi 6, or 5 pi 6, sorry, and take negative of sine of 5 pi 6. Gives me negative 1 half, minus cosine, and cosine there is negative root 3 over 2. So we end up with negative 1 half plus root 3 over 2, which does end up being positive And so either just taking a decimal amount or taking something on the unit circle, either way. And so we end up with these, sorry, I just filled it in with what's not plus. We end up with these three things. So therefore, and let's go back up where we have some more room. So therefore, increasing from negative pi to negative pi over 4, along with 3 pi quarters pi. It is decreasing in between, and so it is decreasing from negative pi quarters to 3 pi over 4. There we are for part 4. We are going to look at our relative and absolute extrema. So we're going to take our y value at each of those points. So we have y, and let's go from left to right. So let's start with our end point of negative pi, and we plug these values back into our regular formula for y. So cos x minus sine x, cos of negative pi is negative 1 minus 0. And so y of negative pi is negative 1. Y of negative 4. So what do we have here? Maybe a little less straightforward. So cosine of negative pi quarters, cosine of negative pi quarters is 2 halves, minus sine of negative pi quarters. Negative pi quarters is down here, remember? And so sine of that ends up being negative root 2 halves. And when we add those together, that's root 2 halves plus root 2 halves is 2 root 2 over 2, which simplifies to just root 2. Y of 3 pi over 4, line 3 pi over 4 is this one over here. And 3 pi over 4, our formula says cosine of 3 pi over 4, which is negative root 2 halves, minus sine of 3 pi over 4, sine of that is root 2 halves, so we're subtracting. So this ends up being negative root 2. And then our last end point, we have y at pi. And at pi, what do we have going on? Cosine at pi is negative 1, and sine of pi is 0. So negative 1. So those are our relative and maximum extrema. We could label these as absolute max. We could label this one as negative root 2 is our absolute minimum. Remember that at pi, those are endpoints, so we can't call it a relative minimum or a relative maximum, because they're not relative, because they don't have any points to one side of them. All right, our next step is to look at second derivative test. Maybe I should be numbering these. So this is part 6. This here was part 5, where we were looking at relative and absolute maximum. Okay, so y double prime. So we're going to take our derivative of y prime, and our derivative of y prime ends up being negative cos x. derivative of negative cos is sine. Where is this going to be equal to 0? Is when cos x sine x. So this gives us possible, and here, this gives us possible points of inflection. And let's draw our number line. Pi to the prime goes from negative pi to positive pi. We have these things that happen at negative 3 pi quarters, positive 1 pi over 4. And we're going to look to see what happens in each of those intervals. So again, we are looking at our second derivative formula for this when we consider all of these values. If we consider something in this zone here, if we're looking in this first interval between negative pi and negative 3 pi quarters, that ends up being negative 5 pi 6, for example. And if I look at the negative of cosine, ends up being positive root 3 over 2. And then I'm going to add negative a half. That ends up being positive in this zone. Between 3 pi quarters and 1 pi quarter, so let's choose 0. So negative cos 0, which is negative 1, plus sine 0, which is 0. So this ends up being negative in between. And so therefore, pi quarters to pi, so say pi halves, negative cosine of pi halves is 0, plus sine is 1. So this is positive. With all of that, we end up with the fact that this is concave up, this is concave down, this is concave up. So making our notes, this is concave up on negative pi, 3 pi quarters, union pi quarters to pi. This is concave down. In between, so negative 3 pi quarters over 4. And there is concave down. All right. We are almost ready. I do have to mention inflection points. We have inflection points where this is changing concavity and it's going from concave up to concave down. And it's defined at all those numbers. So we have inflection points at negative 3 pi quarters. We do have to consider our function value at negative 3 pi quarters. And so we go all the way back to our original equation, and negative 3 pi quarters, cosine of negative 3 pi quarters, minus sine of negative 3 pi quarters. And if we're subtracting those are both root 2 over 2. One of them is negative, one of them is positive, so negative 3 pi quarters comma 0. Pi quarters, so it is going to be comma 0. After all that, we are now ready to start to sketch this. You can imagine that because cos and sine have a range from negative 1 to 1. And if I'm subtracting cos x minus sine x, I'm going to need on outside a range of negative 2 to positive 2. We know I have endpoints of here is pi. It seems to be all of these in between points are pi quarters. So let's call this negative pi to positive pi. Let's call this. And we start to plot this out. All of our points, starting with our intercepts, we have 0, 1 as a y-intercept, we said. We have x-intercepts at pi quarters, 0, negative 3 pi quarters, 0. We had inflection points at pi quarters, 0, and negative 3 quarters, 0. So those are going to be our inflection points. We had negative pi, negative 1. We have a relative and absolute maximum at negative pi quarters, root 2. Root 2 is about 1.4. So we'll put that up here. At 3 pi quarters, we have a minimum of negative root 2. And our last endpoint was pi, negative 1. So what does this look like? It is concave up from this endpoint until we have this concave up. This first interval of concavity goes to negative, and then it changes to concave down. This all seems to fit where we have drawn here. So concave up. Our next interval, this is all concave down until here. It changes concavity, so it is now concave up. And this is our graph. Pi, negative 1. Pi, negative 1. I would probably, we have labeled all of these points in our work. We have called them maximum and minimum and labeled all of these. So how many of these we show, I probably wouldn't clutter the graph up too much. Maybe showing these quarters, root 2, this maximum and this minimum, 3 pi quarters. Maybe those narrowed. All right, so that's what this looks like with curve sketching on top of all this trigonometry work that we've done. And thanks for watching. Hopefully this helps, and good luck with your practice questions.